Okay, so let's go over the HiSET practice test, FPT7, starting with number 1. Number 1 says, what are the zeros of the function? Now, function, remember, whenever you see things like f of x, you can just think of that as y, the output of the function. Well, what are the zeros of a function? Well, it's when the function is equal to 0. So we'll just set that right-hand side to 0 and solve this. Now let's try factoring this. We're looking for two numbers that multiply to negative 24. That means they're different signs. So we're looking for a difference of 2. Well, those two numbers are 6 and 4. Now which one's positive, which one's negative? The sign of the middle term, positive 2, will determine that. The bigger number will be positive, so it's positive 6 and negative 4. And so the factorization is x plus 6, x minus 4 equals 0. And so our solutions are the opposite of the two numbers we found here, negative 6 and positive 4. If you solve those two mini equations, x plus 6 equals 0 and x minus 4 equals 0. So that's our answer, negative 6 and 4. Or you could just plug in numbers if you don't want to factor or you don't want to use the quadratic formula. So remember, both numbers have to be a solution to this. For example, if we try choice A, we can try negative 8. Negative 8 squared, remember put that in parentheses when you're typing that on your calculator, plus 2 times negative 8 minus 24. So that's 64 minus 16 minus 24. That's 24, which is not 0. So we can eliminate A just from that. And if we did B, notice that's negative 6 squared plus 2 times negative 6 minus 24. That's 36 minus 12 minus 24. That is 36 minus 36, or 0. So we're good there. But you have to also check 4. 4 squared plus 2 times 4 minus 24. That's also 16 plus 8, which is 24. 24 minus 24 is 0, so that checks out. So B is our solution. If B wasn't the answer, you could go through C, D, and E and check those numbers. You can probably guess that 24 is not going to be a solution because 24 squared is going to be big. So that's probably not a solution. So that's an easy one to eliminate. Okay, number 2. What is the sum of 5x squared plus 3x minus 7 and 12x plus 12? This is collecting like terms. The easiest way to do this is just to find terms that are like. 5x squared here. Are there any terms with x squared here? No. So we know the first term is going to be 5x squared. So we already know that these are out. And now we can check our x terms. 3x plus 12x, that's 15x. Okay, that checks out with these two. So the determining factor is negative 7 plus 12, which is 5. So A is our answer. You can also line these up kind of like you're doing integer addition. 5x squared plus 3x minus 7, 12x plus 12. And just add down the columns. 5x squared plus 15x plus 5. Number 3. Aisha has $100 saved from her job. She wants to buy as many charms for her bracelet at $4 each and earrings at $5 per set as she can without spending all of her money. The inequality represents her spending, where X is the number of charms and Y is the number of sets of earrings. So we have an inequality here. $4 times the number of charms plus $5 times the number of earrings, sets of earrings. That sum, that combination has to be less than $100. Now you could graph this inequality, which basically is equivalent to graphing the line 4x plus 5y equals 100, and then find out which of these points fall below that line. But since, as we'll see, many of these points end up falling very, very close to the line or even on the line, it's probably the easiest way to solve this problem is just to plug in points. So 4 times 16 plus 5 times 8, that equals 104. That's larger than 100. That's larger than 100, so that's eliminated. 4 times 15 plus 5 times 8. That's exactly 100. But remember, we need the total cost to be less than 100. She doesn't want to spend all of her money. So that's out. 4 times 9 plus 5 times 13. That's 101. Again, that's too big. 4 times 6 plus 5 times 15. That's 99. That is indeed less than 100, so that's it. That's our answer. You could check E as well if you want, just to be sure. 4 times 5 plus 5 times 16. And again, that one's equal to 100 as well. So that's ruled out. Which of the following graphs represents the relationship between x and y if y always increases as x increases? So as x increases, y always increases. It looks like that's the case here in the first option. X is increasing, y is increasing. Number 2, definitely not. Y is decreasing as x goes to the right. So that's out. And I'm going to skip to 4 here because this one, as x goes to the right, y is increasing in both sections of this graph. There and there. Y is increasing at a different rate, but it's still increasing. So that checks out too. The tricky one here is 3. As we go to the right, this part here, y is indeed increasing. But in this area here, y is constant. So y is not increasing. It has to be strictly increasing. So our 2 legitimate graphs are 1 and 4, so the answer is A. Number 5. A restaurant is at 75% capacity with 120 patrons. How many people are in the restaurant when it is at 100% capacity? So whenever we see a percent, we got to think, what's that a percent of? Well, it's a percent, 75% of the full restaurant. Do we know the full restaurant? No, that's what we're trying to find out. We can just call X the full capacity. Well, that means 75% of X, the full capacity, is 120. So that makes this equation 0.75x equals 120. X equals 120 over 0.75, which is 116. Or you could notice that you're looking for the whole, the total, and if you remember that that's the part divided by the percent, you could get it that way too. As far as eliminating things, you could note that the whole, because 120 is 75% of the full capacity, you know that the full capacity has to be more than 120, so A and B you can eliminate pretty quickly. Number 6. Several students are going to ride their bikes from the city park to Lake Gansa, a distance of 25 miles. They will ride at an average rate of 10 miles per hour. What is the latest time they can leave the park in order to arrive at the lake by 11 a.m.? So this is a classic distance rate time problem. You can write D equals RT and fill in the distances. 25 miles equals 10 miles times T. In other words, time is the distance divided by the rate, or 25 miles divided by 10 miles per hour, which is 2.5 hours, 2.5 hours. So really we just need to subtract that from 11 a.m. and you get 8:30 a.m. Let's look at number 7. Ms. Lund placed a 7-foot ladder against a wall with the base of the ladder 4 feet away from the wall. She decided that a different 10-foot ladder needed to be used. If Ms. Lund wants the longer ladder to rest against the wall at the same angle as the shorter ladder, about how far away from the wall should she place its base? So time to draw a picture. Here's our wall. There's the ground. And there's our ladder, our 7-foot ladder. Now that's a right angle, so you might already be thinking, oh, am I going to have to use Pythagorean theorem? Maybe, but there are 2 triangles, as you'll see. Here's our 10-foot ladder at the same angle. Now we know, and we want to know, what this distance is. So this is a similar triangles problem. We have 2 triangles, a small triangle and a large triangle. We have a small triangle here and a large triangle here. Since they're similar triangles, corresponding sides have the same proportion. So the ratio of the small triangle to the large triangle would be, well, let's use the numbers we know. It's 7 to 10. That ratio has to be the same as the base on the small triangle to the base of the large triangle, which is x. And there's our proportion. You can cross multiply diagonally to get 7x equals 4 times 10, or 40, or x is 40 over 7, which is about 5.7. That's answer A. So question 8 on the left refers to the following information. So we got a couple graphs that we're going to just kind of skim and get an idea of as we read what they're about. So the graphs below show the total value in US dollars of the imports and exports of country W. So these are both W's imports and W's exports. So it's trading with three countries, X, Y, and Z. Okay, so let's just take a look at the question. What percent of country W's total imports was from country X? So we only really care about the import graph. We don't care about the export graph. If we want percent of country's total imports, so we're taking percent of the total imports. The percent is the part divided by the whole. The whole here is the total imports, and the part is imports from X. Well, from X, which we will use, it's $40 million. From Y, it looks like we got 80. And from Z, we got 40 again. Add those up, you get 40 plus 80 plus 40, that's 160. And from X, we have 40. We don't have to include the million in the actual calculation. We'll just do 40 divided by 160, or a fourth. That's 25%. That's it. Okay, number 9. What is the solution to 3x squared minus 2x plus 4 equals 0? This is similar to problem 1, except there's no easy way to factor this, and we kind of have to use the quadratic formula. And on top of that, we're going to have to deal with imaginary numbers, which involves the square root of negative 1. And that means we're going to have a negative number underneath the square root. Every single one of these options has the letter I in it. I means the square root of negative 1, so we can expect to find negative numbers underneath our square root. So let's remember the quadratic formula. If you call a leading coefficient A, the negative 2 is B, and the 4 is C, then the solution to this quadratic equation is negative B plus or minus square root of B squared minus 4AC all over 2A. Let's fill in our numbers. Negative B, remember B is negative 2, don't forget that. So negative B is positive 2 plus or minus the square root of, so B squared is negative 2 squared. That square is going to kill off that negative, so we really don't need to worry about the negative there. Minus 4 times A, which is 3, times C, which is 4 again. And that's all over 2A, which is 2 times 3. So this is 2 plus or minus, that's 4 minus, 4 times 3 is 12, times 4 is 48, so 4 minus 48, so that's why we're going to get a negative number underneath the square root. And this is 6 here. 2 plus or minus the square root of negative 44 all over 6. Now from here, if you wanted to stop, you could eliminate a couple, because there's no factors, there's only going to be a factor of, well, negative 1 and 4 and 11. There's no 13s, so we can get rid of D and E. So now it's between A, B, and C. It's only one more small step to get to the answer, and that is to split up that number underneath the square root. And I already did. It's negative 1 times 4 times 11, so I can write that as 2 plus or minus the square root of negative 1 times the square root of 4 times the square root of 11. And that's all over 6. And so that square root of negative 1, we call that I. The square root of 4 is 2. So this is 2 plus or minus 2i times the square root of 11 all over 6. And so you might see that 2 plus 2i, you might think, aha. But remember, we can simplify this just a little bit more. The 2 in both the top terms, you can factor that out and basically cancel it with the 6 on the bottom. I'll write it like this. 1 plus or minus I squared of 11 all over 6. And the 2 and the 6 cancel. 2 divided by 2 is 1. 6 divided by 2 is 3. So our final answer here is 1 plus or minus I square root of 11 all over 3. Looks like that's B. All right, let's look at number 10. An artist has all her paintings framed with a 3-inch wide border. She has a painting to be framed that is 1 foot by 1.5 feet, 1.5 feet. What's the question? Which of these following measurements represents the perimeter? So now our perimeter, remember perimeter equals twice the length plus twice the width. Basically, it's just the distance around the whole thing with the frame. And the thing to notice is that we've got inches and feet here, so it's best to convert everything to the same unit. Since our answers are in feet, we probably want to convert our 3 inches here and here to feet. But a nice thing to notice is that 3 inches plus 3 inches is 6 inches plus 1.5 feet. But 6 inches is a half a foot. 0.5 feet plus 1.5 feet, that's 2 feet. Same thing goes here. We got 3 inches, that's a half a foot, plus 1 foot, that's 1.5 feet. So we've got 1.5 feet here. Now we've got to double each of those. 2 times 2 plus 2 times 1.5. We get 4 plus 3, which is 7 feet. E. Now 11. It takes 1 bag of chocolate chips to make 72 cookies. How many bags does it take to make 18 dozen cookies? We have a rate here. 1 bag per 72 cookies. They're asking us about 18 dozen cookies, so we might as well convert our 72 cookies to dozens. How many dozens is 72? Well, divide by 12. So it looks like it's 6 dozen. So that means we got 1 bag per 6 dozen. And that rate has to be the same as, we don't know how many bags, per 18 dozen. Well, we can give a variable to this and solve that proportion if you like, or just notice that if we triple the number of cookies, multiply the number of cookies by 3, then we have to multiply the number of bags by 3. So it has to be 3 bags. For 12. Each time a coin is flipped, it has a 50% chance of landing on heads and a 50% chance of landing on tails. The coin will be flipped 3 times. What is the probability it will land on tails all 3 times? There's a couple ways to go about this. One way is to just list out all possible outcomes. Remember, the probability of something happening is the number of desired outcomes divided by the number of total outcomes. And so you could list them all. There's several of them. You could list heads, heads, heads. Heads, heads, 1 tail here. Tail is the second flip, or tails as the first flip. Or you could have all tails. Or you could have 2 tails with a head as the last flip, or heads as the middle flip, or heads as the first flip. And that's it. There are 8 possible outcomes. So that's our denominator. Out of that, how many of those outcomes are all 3 tails? Tails all 3 times? Well, there's only 1 of them, so our probability is 1 out of 8. Another slightly quicker way to do this might be to notice that if you want to find the probability of 2 things that are happening, and those 2 things don't affect each other, don't change the probability of each other, they're called independent events. And flipping a coin is an independent event. The result of one coin flip will not affect the result on the next flip. So, if that's the case, then the probability of both things happening is just the product of the 2 probabilities. So, in other words, the probability of getting a tail on 1 coin is 1 out of 2. The probability of getting a tail on 2 coins is 1 out of 2 times 1 out of 2. And the probability of getting a tail on all 3 coins is 1 out of 2 times 1 out of 2 times 1 out of 2, which again is 1/8. Either way you do it, answer is A. Number 13. An electronics store offers to finance the purchase of any single item with 0 interest for 1 year with a down payment of $60. The rest of the purchase price will be split evenly into 4 quarterly payments. Which of the following equations represents the relationship between the amount, A, dollars, of each quarterly payment, and the purchase price, S dollars, of an item under this offer? So I'm just going to remind myself what things are. So we got a down payment is $60, and then 4 payments on top of that. And they're each $A. Our total payment is S dollars. So imagine you had S dollars for the whole price. How would you calculate the quarterly payment? Well, you'd first subtract off your $60. Well, then you split that answer into 4 payments. Divide it by 4. And that should be the amount per payment. A. If you weren't sure about that calculation, imagine S to be a number. Say it was $1,000. You would subtract off 60 and then divide by 4 to get your total payments. Another way you could do it is by imagining how you would build up to the total price from the payments. We would have 4 payments. Each of them are $A each, so that's 4 times A, plus the $60 down payment. That should be my total price, S. And then solve. Solve for A. It basically tells you the exact same calculation here. When we subtract 60 from both sides, it's 4A equals S minus 60. There's the subtracting the 60. And then divide that answer by 4. Either way, you'll get that same answer. Number 14. Let g of x equals x squared minus 1. What is the average rate of change of the function from x equals 3 to x equals 6? Again, g of x, we can just think of that as y, the y value. What is the average rate of change? Average rate of change is simply the slope of the line through 2 points on a graph. And the 2 points we were concerned with are the 2 points where x is 3 and x equals 6. We'll have to figure out what the y values are at those points, but we can plug 3 and 6 into our function to find out what those are. So our graph will look something like this. We're looking for the rate of change, the slope of the line through those points. So to find the y values, let's just plug in x equals 3 into the function. Y is 3 squared minus 1, or 9 minus 1 is 8. So our first point is 3, 8. When x is 6, y equals 6 squared minus 1, or 35. So now we got 6, 35. We've got 2 points. The slope of the line through those 2 points is change in y over change in x, rise over run. 35 minus 8 divided by 6 minus 3. So that's 27 over 3, or 9. Just from drawing a rough graph, you might be able to guess that 1/9 is too small of a slope, but in reality, it's probably quickest just to calculate the slope between those 2 points. Number 15. Which expression gives the distance between point S and point T? This is distance between 2 points, which, as we know, is the Pythagorean theorem. The distance from S to T is our D. We've got our 2 legs of our triangle. We can just count how long they are. 1, 2, 3, 4, 5, 6. This is 6. 1, 2, 3. This is 3. So it looks like the distance squared is the sum of the squares of the other 2 sides. So the distance is the square root of 6 squared plus 3 squared, which is B. Number 16. Melody is making a spinner with a 12-inch diameter for a game. She will divide the falling spinner into sections, A, B, C, and D. What is the area in square inches of the section C? So we really only care about the area of section C here. Let's figure out what the area of a circle is. Area of a circle is pi times the radius squared. The radius is half the diameter. Do we know the diameter? Let's check. 12-inch diameter, here it is. The diameter is 12 inches, so the radius must be 6 inches. So the area of our whole circle is pi times 6 squared. In other words, it's 36 times pi. Now, I could multiply that out and get a decimal, but notice all of these answers include the symbol pi, so they're not multiplying it out, so I don't think I will either. I'll just leave it at 36 pi. That'll be an easier number to work with anyway. Now, to find the area, that's not our answer though, and notice they do give you 36 pi here to kind of trick you. That's the area of the entire circle. We want the area of just section C. So right now we could eliminate two choices. We know it's not going to be bigger than 36 pi, and it's not going to be equal to 36 pi, so it's going to have to be one of these other three. Now, a thing to notice is that the area of this sector, this 45-degree sector, it's going to be a fraction of the whole, and that fraction is going to be the same as the fraction 45 over a whole entire revolution around the circle. Now you could add up these degrees to find out what that is, or it's probably not a bad thing to just know that an entire revolution around a circle is 360 degrees. So the area of C should be 36 pi times the fraction 45 over 360. Now 45 over 360 is 1/8, so this is 36 pi times 1/8, which if you take 36 and divide it by 8, you're going to get 4.5. 4.5 pi is your answer, which coincidentally is C. Number 17, a lighting designer created a program for the opening of a stage show. When the show starts, 10 lights are on. Every 30 seconds, one more light comes on. If T is time in minutes and L is the number of lights that are on, which function best models the number of lights that are on after T minutes? Okay, that's a lot, but let's just make note of the important stuff here. When the show starts, 10 lights are on. So that's a starting value. 10 lights are on. Every 30 seconds, every is a keyword that tells me this is going to be a rate. Every 30 seconds, one more light comes on. So that's a rate, one light per 30 seconds. So to start with, we've got 10 lights. We get one light per 30 seconds. So we need a relationship between the time and the number of lights that are on. This is going to be a linear thing because we've got a rate and we've got a start value. A rate is going to be our slope. Our start value is going to be our y-intercept. Now, the time is in minutes, so we can't have seconds down here. We need to change this rate to minutes. Well, that means it's 2 lights per minute. So that's our slope, 2. And our y-intercept is 10. So our number of lights is equal to 2 times the time, 2 lights per minute times the number of minutes that have passed, plus the 10 lights that were on at the beginning. That's B. As you are making this, you could eliminate some of these choices pretty quickly. As long as you understand, all of these are linear equations, so that would give you a clue that we're looking for a linear equation. So we're looking for a slope and a y-intercept. So you could quickly notice that 30, the slope can't be 30. It's not 30 lights per minute. And knowing that the slope is in lights per minute is important here. It can't be 10 lights per minute or 10 lights per minute here. So that eliminates all of those. And so really it would be coming down to both of these. And knowing that the slope is in lights per minute would eliminate that one too. But by that time, you've basically got the equation anyway. Number 18. A radio station ordered hats and coffee mugs to give away as prizes. A total of 1,000 of these items were ordered, and 3 times as many coffee mugs were ordered as hats. In which equation does H represent the number of hats ordered? Well, H is the number of hats. We know that. What else do we know? We know that the mugs is 3 times as the hats. 3H. We also know that the sum of those, H and 3H, is the total. 1,000. So that means 4H, combine like terms. We get H, as we solve, divided by 4. H is 1,000 divided by 4. That's E. Number 19. Volunteers are needed to do a total of 60 hours of work at a concert. The shortest volunteer shift is 2 hours, and the longest is 3 hours. Which inequality shows V the number of volunteers needed? First of all, a 3-sided inequality is a way to indicate when a number is between two numbers. For example, 1 is less than x, a number which is also less than 10. That's representing a number between 1 and 10, non-inclusive. If you include 1 and 10, you would include an equal sign. Important thing to notice is that these signs point the same direction. So that's how you could eliminate some choices here. So A, we see that the two symbols are not going in the same direction. We can eliminate that. And also with C, the two symbols are not going in the same direction. So we can eliminate that. Also, notice D here, it's saying that 20 is greater than or equal to V, which is in turn greater than or equal to 30. And what that's implying is that 20 is greater than or equal to 30, which is not true at all, so we can eliminate that one as well. Okay, so there's really only two other choices left, and it's really just between whether it's a less than or or equal to situation. And determine which one of those to pick, or to just solve this problem in general, it's probably a good idea to just look at the extremes. What happens if all of the shifts were 2 hours? We have a total of 60 hours to divide amongst all of our volunteer shift workers. If all the shifts are 2 hours, then you can divide 60 by 2 to give you 30 volunteers. That's at the maximum. And at this point, you could say, is it possible that all the shifts are 2 hours? Yeah, because the shortest volunteer shift is 2 hours. There are volunteers whose shifts are 2 hours. So is it possible that all of them could be 2 hours? It's possible. And so you could have exactly 30 volunteers. And so the answer should be E. But let's check the other extreme. What if all these shifts were 3 hours long? Well, then that means we have 20 volunteers. That means the number of our volunteers has to be between 20 and 30. But we can include 20 and 30 in those limits. So the answer is E. Number 20. Jenna bought some apples for $1.25 per pound and some avocados for $4 per pound. Altogether, she spent $14.25 for 7 pounds of apples and avocados. What is the total number of pounds of avocados Jenna bought? Let's give that a variable. A is the pounds of avocados. And since we can't use A for apples, I'll just use B for the pounds of apples. I don't know if I'll need that variable, but we'll have it. Avocados were $4 a pound. Apples were $1.25 per pound. The total of all of these is 7. Total A plus B is 7. We know that the pounds of apples is just 7 minus the number of avocados. So if the avocados is A here, then our apples, B, is just 7 minus that. So it would be 6, 5, 4, 3, 2. So for A, we have $4 times 1 pound of avocados plus $1.25 times 6 pounds of apples. We get 11.5 or 11.50. Too small, so A is out. 4 times 2 pounds of avocados plus $1.25 times 5 pounds of apples. $14.25. Hey, we got lucky. That's what we want. The total spent was indeed $14.25. So that's the answer. B. If you didn't hit that early enough, it won't take too long to get through all 5. But if you were quick at it, you could create an equation and solve it. You can kind of model this calculation that we have already. 4 times the number of avocados plus 125 times the number of apples, which is 7 minus A. That equals 14.25. And you can solve that equation. You would distribute this 1.25. You get 8.75, 8 3/4, minus 1.25A. 4A minus the 1.25A, that's going to give you 2.75 times A plus 8 3/4, 8.75. Subtract 8.75 from both sides, and you get on the left 2.75A equals 5.5. Dividing by 2.75, and you will get A is indeed 2. Okay, number 21. Khalid is 56 years old. Kathleen is 6 years older than Brody. The sum of Kathleen's and Brody's ages is half of Khalid's age. How old is Kathleen? Okay, let's just write down some stuff. Khalid is 56. Okay, great. Kathleen is 6 years older than Brody. And Kathleen and Brody's age sum up to half of Khalid's age. Well, let's figure out what half of Khalid's age is. Well, if he's 56, then half of that is 28. So that means the sum of the two ages is 28. So we have an equation here with two variables, but we have another equation that relates those two variables as well. If Kathleen is Brody's age plus 6, we can just replace Brody's age plus 6 in for Kathleen's age. Brody's age plus 6, which is Kathleen's age, plus Brody's age is going to be 28. B plus B is 2B, plus 6 is 28. Solving, we get 2B. Subtracting 6 from both sides, we get 22. And divide both sides by 2, we get 11. Brody's age is 11. Great. Is that what we wanted? They wanted to know Kathleen's age. Now notice they did give you 11 here to trick you, but that's not the answer we want. We want Kathleen's age, which is 11 plus 6, or 17. That's the one we want, 17D. Always a good idea to go back to the problem and check to see if your answer is the one that they want. Number 22. A backpack is on sale for 25% off. After the discount is taken, a 7% sales tax is applied. If the original price of the backpack is P, which equation represents the final cost, C in dollars, of the backpack? So we're going to take 25% off, and then we're going to add 7% for sales tax. So it's a percent decrease and then a percent increase. Remember, for a percent decrease, we have a multiplier of 100% minus your percent decrease, which is 25. So this is 75%. And we convert that to a decimal, 0.75. In other words, if it's 25% off, it's 75% on, or left over. And that multiplier, that 0.75, is what we can multiply by the original price to get the sale price. Likewise, the percent increase, the multiplier that we're going to multiply our original price by is going to be 100% plus the percent increase, which in this case is 7%. And so that's 107%, or as a decimal, 1.07. So what this all means, we take original price P, we multiply it by our 75%, 0.75, to get our discount price. Then we multiply that by 1.07 to calculate the tax. And that's C, that's the final cost. And it looks like that's E. 23 and 24 refer to the following information. So we got, I'm just going to scan the table here real quick. We got 5 factories, looks like. There's dollar amounts in the columns. Let's figure out what those dollar amounts mean. A newspaper published the table below. It shows a sample of the daily wages paid by 5 local factories. So these are daily wages for 5 workers in each factory. 23 asks us, what is the median daily wage reported by factory D? So here's factory D. To find the median of a set of numbers, we just put them in order and then take the middle number. Or if you have 2 numbers in the middle because you have an even number of values, you would take the average of the 2 middle numbers. So here we have 200, then 205, then 210, and then 2 220s. So it looks like 210 is our middle number. That's our answer. Now, median is not to be confused with mean. So mean is just where you add them up and then divide by the number of numbers. You add all those up and then divide by 5. That would be the mean, not the median. 24 does ask us about the mean. It's asking us about the average wage. Usually when we use the word average, we're usually talking about the mean. So 24 says the worker at factory A who made $180 per day received a raise and now makes $195 per day. If this value were changed in the table, how much would the average wage increase for factory A as a result of this raise? Now, there's a long way to do this and a short way. You could just replace this one with 195, add them up, divide by 5, and find the new mean, and then compare that to the mean with just the original 5 numbers, and subtract. That would be fine. You could definitely do that. I'm going to be a little trickier here, just to save some time. I know that the original average, was the sum of the numbers divided by 5. I don't really care what the sum is, but I know that the sum is divided by 5. That was the original average. The new average, though, the new mean, is the sum but the sum has an extra $15 on it because it went from 180 to 195. So that's a difference of 15. So the sum just changes by 15. And when we divide that by 5, we can split that fraction up into sum over 5, whatever sum is, plus 15 over 5. Well, the sum over 5, well, that's just the original average. And 15 over 5 is 3. So it looks like our average increased by $3. That's the answer. Finally, number 25. Lydia and Claudia have the same number of charms. It's important to notice. They have the same number of charms in their collections. Lydia started with 6 charms and bought 3 more packs. Claudia started with 9 charms and bought 2 more packs. If each pack had X charms, which equation can be used to find X? So let's just calculate how many charms they each have using the value X for the number of charms in a pack. So let's just note that X is the number of charms per pack. So it's a rate, basically. If we multiply that by the number of packs, we get the number of charms in that number of packs. Okay, and we also know that Lydia's charms equals Claudia's charms. Well, Lydia's charms is 6 charms plus 3 more packs. Each pack has X charms in it, so you take 3 times X, you get the total number of charms that Lydia has. Claudia, on the other hand, has 9 charms, and she bought 2 more packs, and each of those packs has X charms in it, so you take 2 times X. So on either side here, we've got the number of charms that each of them has, and we know that that's equal. They have the same number of charms, so that's it. 6 plus 3x equals 9 plus 2x. That's this one, by the way. They put them in the opposite order, but that's okay. 3x plus 6 equals 2x plus 9. That's equivalent. Since this is addition, we can change the order. So the answer is E, and that's it. All right, I hope this helped. Keep practicing. See you next time.